For today's lesson, we're going to be able to solve radical equations, reviewing what we've done in the past. So here we want to solve our equation. As we talked about before, working with radicals, we want to get the radical alone on one side of the equation, and then we can undo it. So here, for our first step, we could subtract 7 from each side of the equation. Therefore, we've got the square root of the quantity x plus 1 equals 3. Now remember from before that a radical like this is to the power of 1/2. And so we need to undo that power. So we want to ask ourselves, well, what can we multiply 1/2 by to make 1? 1/2 times 2 is 1. So the power that we need is to the second power, which means we're going to square each side of the equation. That will undo the radical on the left-hand side and give us 9 on the right-hand side. At this point, to solve for x, we can subtract 1 from each side, so x equals 8. As always, when you're solving your equations, you should check and verify your solution, especially with these because we've seen that we've had extraneous solutions come up, therefore giving us no solution for the equation. So by doing our check, we take our value for x and put it to the original equation and see if it's a match. So now we've got the square root of the quantity, 8 plus 1, which is 9, and we know the square root of 9 is 3. 3 plus 7 does give us 10, therefore x is a solution to the equation. Let's take a look at another example. Here we have the square root of x plus 4 equaling the square root of 2x minus 1. Here we have a radical, a square root, on each side of the equation. And again, we need to undo that. Just like we've done in the past, we know a square root, a radical like this, is to the 1/2 power, and we need to undo that. So in order to undo something to the 1/2 power, like we said before, we square it because 1/2 times 2 is 1. Therefore, we have an equation x plus 4 equals 2x minus 1. Just like we solve your other linear equations, typically we start with your lowest variable first and undo that, so we could subtract x from each side. Then we can combine our like terms for our constants. We could add 1 to each side. This is looking like x equals 5. Again, we have to verify that this is a valid solution to our equation. So let's take it and substitute it back into the original and make sure that it's balanced. So here on the left-hand side, we have 5 plus 4, which is 9. So we have the square root of 9 here on the left. On the right-hand side, we've got 2 times 5, which is 10. 10 minus 1 is 9. The square root of 9 is equivalent to the square root of 9. Both of those are equal to 3, so we can see that we have a valid solution of 5. So let's try another one. Here we want to solve our equation. We have the square root of the quantity 6 minus x equals x. Again, taking a look at the equation, we can see we have a radical alone on one side, and we want to undo that. So again, to undo a square root, we're going to square each side of the equation. Therefore, we have 6 minus x equals x squared. Now, because we have the x squared, that's making this a quadratic equation, and we know all quadratic equations have to equal 0 before we can solve them. So we need to make that happen. So in order to make a 0 for this equation, I'm going to add x to each side and subtract 6, putting the 0 on the left. It's your preference where you'd like to put the 0 for your equation. And if you want to put it on the right, you could just subtract x squared, and you'd have a negative x squared minus x plus 6 equals 0. Whenever you have the quadratics, typically with your methods, we like to try factoring first to see if there's a greatest common factor, because if it is factorable, that's probably the quickest method for solving. If not, you could also use the quadratic formula to solve it. Some of you might like to complete the square, or you could always graph it to find your solution. Well, here the greatest common factor would be 1, so we'll skip that part and think about what times what gives us negative 6, what plus what gives us 1. So one of those values has to be negative and the other is positive, and I know 3 and 2 can make a 6, and if the 3 is positive and the 2 is negative, that will meet both requirements. So here are my two factors. Now that it's factored, we take each factor and set them equal to 0 and solve. So x plus 3 could equal 0, or x minus 2 could equal 0. In order to solve the x plus 3 equals 0, we could subtract 3 from each side. In order to solve the x minus 2 equals 0, we could add 2 to each side. So it looks like we have two possible solutions of negative 3 and 2. As always, we need to check and verify. Do both solutions work? Do one solution Does one solution work, or do neither solutions work? So let's check the -3 first by substituting that into our pattern. And so now we've got 6 minus -3 equals -3. So let's think about this. 6 minus -3, that's a 9. So we have the square root of 9 is equal to -3. We know the square root of 9 is equal to 3. That's not true, so it has to be an extraneous solution. Then if we check the 2, 6 minus 2 is 4, and that's underneath our radical. And we know the square root of 4 is 2. 2 does equal 2, so that's true. So this one has one solution, and that solution is x equals 2. Let's try one more here. We want to solve our equation. We have the square root of the quantity x plus 2 equals x minus 4. And again, to undo your radical, we need to square each side of the equation because it's the 1/2 power, making it a 1. So on the left-hand side, this would just be x plus 2. On the right-hand side, we have to remember what happens when you have a quantity squared. That means you have 2 of those items being multiplied together, so you have to distribute x minus 4 to x minus 4. We know by distributing we would have x squared minus 4x plus 16, which simplifies to x squared minus 8x plus 16. That will be equal to x plus 2. Well, again, since I have an x squared, I can see I have a quadratic equation I'm working with, so we have to make it equal to 0. So let's make the 0 on the left-hand side by subtracting x and subtracting 2. So we're going to have 0 equals x squared minus 9x plus 14. Again, since it's a quadratic, you have a couple ways of solving it. We could try factoring, we could do the quadratic formula, we could complete the square, we could also graph it. Let's see if it's factorable. So looking at all the pieces here individually, the greatest common factor is 1. So let's think about what times what gives us 14, what plus what gives us -9. Well, 14 I know comes from 7 times 2, and I could probably use a 7 and a 2 to make a -9. To make both of them true, both items would have to be negative. So we've got factors of x minus 7 times x minus 2. When you're factoring, remember, we're trying to make it equal to 0. That means one of those factors has to be 0. So it could be x minus 7, or it could be x minus 2. In order to solve for a factor here on the left, we could add 7 to each side, and on the right, we could add 2. So it looks like our two possible solutions are 7 or 2. Now we have to check to see, do they both work, does one work, or do neither of them work for the equation? So we can set up both checks. So we're substituting our value for x to each place in the equation where it appears. So here on the left, we have the square root of 9 equaling 3. So the square root of 9 we know is 3. 3 does equal 3, therefore that's a valid solution, x equals 7. Now let's check our solution of 2. So again, substituting it into each place in the equation where it occurs. So underneath our radical here, we're going to have 4, and that's going to equal -2. So we've got the square root of 4 equals -2. Well, we know the square root of 4 is 2. 2 does not equal -2. It's just showing us that it's an extraneous solution because it's not valid. So we only have one solution for this problem, which is x equals 7. Now it's your turn to do some more practice. You're going to work on your Unit 9, Day 8 worksheet. You have the problems given to you here. Those are your last night's homework problems, sorry. You have it in your packet, Unit 9, Day 8. You're going to work on solving those functions. It's a puzzle worksheet, so remember at the end, looking at your answer, you can check and see if you're on target and substitute the letters into the values accordingly and come up with the message of the "Did you hear about the" puzzle page, and we'll check those in our next class. Our next class will also be doing a quiz to show your level of understanding with how you can solve your radical equations.